Okay, let's get started with this right away. Today we are going to talk about solving equations using multiplication or division. In example 1, we are going to be using division to solve our first problems here. And just like yesterday, and we're not going to write down any notes, but just like yesterday, you must do the same thing to both sides. So if you divide by 5 to one side, you must divide by 5 to the other side. Same with multiplying. Whenever you multiply to both sides, you must do the same. And also, you always want to be working with the side of the equation that the variable is on, because you're trying to get the variable by itself. So when you're deciding what number to divide by or what number to multiply by to both sides, you want to use the number that's on the same side as the variable. Sometimes that variable is on the left side, sometimes that variable is on the right side. So in example 1 here, we're going to use division to answer our problems. And the reason I know we're going to use division is because it's 12w, which means 12 times w. And I always want to use the inverse operation. The inverse operation of multiplying is to divide. So the inverse of multiplying is divide. So to answer this problem, I'm going to divide to both sides. What number do I divide to both sides? Well, I'm going to divide this 12 right there. That's the number that's being multiplied to the variable. So that is why I'm going to divide it. So my example A, there's my problem. Here's how you show your work. We are going to use a fraction bar. I don't want you to guys use your division symbol with the line with 2 dots. I want you to use a fraction bar. Makes it real simple. I'm just going to basically underline. And divide that by 12. 12 divided by 12 is 1. 1 times w. This is our identity property. 1 times w is w. On this side, I must do the same thing. So I divide that side by 12. And negative 96 divided by 12 is, well, 96 divided by 12 is 8. A negative divided by a positive is a negative, and I get w equals negative 8. And again, you can always check your work by plugging it in. Negative 8 times 12. 8 times 12 is 96. Positive times negative is a negative. You can use your calculators to do these also. For example B, I'm going to first identify, I got to find where my variable is. My variable is the c. It's right there. Okay, what's being multiplied to the c is the 5. So in order to answer this problem, I'm going to do the inverse of multiplying by 5, and that's to divide by 5. So I'm going to divide by 5 to both sides. I get negative 15 divided by 5. Negative 15 divided by 5 is negative 3. On this side, 5 divided by 5 is 1. 1 times c is c, so all I'm left with is c. So c equals negative 3. I can plug that back in to check my work. I'm going to go on to my next example. If you need to pause, go ahead. In my next example, example 2 here, I'm going to be using multiplication to solve my problem. Because in the original problem, I'm dividing by 12. Here's my variable. So in example A, I have A divided by 12 equals 11. So here's my variable. What am I doing? I'm dividing by 12. So I want to use the inverse operation of dividing by 12, and that's to multiply by 12. Now here's how I'm going to show my multiplication. I'm going to use parentheses. You could use a dot if you want. That also works. I'm going to make a big 12 off here to the side. 12 here and 12 there. Now technically 12 is the same as 12 divided by 1, because anything divided by 1 is itself, so 12 divided by 1. That becomes important because 12, and then I end up later doing the divided by 12, they become 1. 1 times a is a, so that leaves me with the a. Now you don't have to show that divided by 1 every time. You can just put a times 12 out there, but you have to remember, you're not doing 12 times 12 on the bottom to get 144. The 112 you've added in or put in is on top. It's in the numerator, where the original 12 is in the denominator. They end up dividing each other out, 12 divided by 12 to get 1. On the other side, I do 11 times 12, and 11 times 12 is 132. I don't have any negatives to worry about. And there's my answer. I can check my work. 132 divided by 12 is 11, so I'm good. In example B there, I have y divided by negative 10 equals 7. So in order to solve this one, since I'm dividing by negative 10, the inverse is to multiply by negative 10. So I'm just going to put a negative 10 on that side and a negative 10 on there. Those are going to end up dividing out to be 1, which leaves me with my y. And you can just show that by crossing them off like I did. So I get y equals, and then 7 times negative 10 is negative 70. 7 times 10 is 70. Positive times a negative is a negative, so I get y equals negative 70. I can check my work. Negative 70 divided by negative 10. Well, negative divided by negative is positive. 70 divided by 10 is 7. So that's how I can double check my work to make sure I'm right. Okay, I'm going to move on to the next slide if you need to pause. All right, in example 3, writing and solving an equation. So this one I really want you to focus on writing an equation where you either have to multiply or divide to solve it. So that's what I'll be looking for in your tests and quizzes. So if you don't write them that way, I'm not going to give you full credit because we're practicing that skill. So here, the SOHO spacecraft detected solar wind traveling at 2 million kilometers per hour. The sun is 150 million kilometers from Earth. About how long does it take the solar wind to reach the Earth? This one I'm actually going to use a formula that you may or may not know, but it comes in handy in problems like this, where anytime you have a rate here, like 2 kilometers per hour, that's a rate. That word per is key for that. And it's talking in distances and time. Okay, so per hour is our time, and then 2 million kilometers, or kilometers, is our distance. So anything that has time and distance, and then we're talking about a speed of some point, this formula becomes very helpful. And that is distance equals rate times time. You don't have to have that memorized quite yet, but that is a good formula to learn and is used a lot in math problems. So that's a good one to know. That's distance, d, equals rate times time. Okay, let's plug that in and fill out our problem then. I know my distance because the sun is 150 kilometers from Earth. So that's how far away I am. So I'm going to put 150. Now because they are both in million, I'm just going to leave it at 150. Okay, because I know that is a million. I could put all the zeros if I wanted, but since they're both in the same million per kilometers, I can leave that at 150 and just know that my answer is going to be in million kilometers, unless they cancel each other out, which they will. That's my distance. My rate is my 2 million kilometers per hour. My rate has the word per in it. So anytime you see the word per, that's going to be your rate. So that's going to be 2. Again, I'm going to drop the million. Okay? Now if you want to write that in or whatever, you can, but I know they're both in millions, so that's going to work out. And then my time, I don't know. About how long does it take? That's my variable. My question is asking me. Usually the question indicates what your variable is. How long? I don't know. So I'm going to use t for time. Now I have an equation. Now I can divide this by 2. Remember, that's 2 million. And I can divide that by 2. That is 150 million and 2 million. So the millions end up crossing each other out because they're both in millions. They cross each other out. So now they're gone. I don't have to worry about them. If you wanted, you could have written the word million or put all those zeros, but they would cross each other out. Now I can do the work here. The 2's are going to cross out. That's going to leave me with t. 150 divided by 2 is 75. So I get 75 equals t. What does that mean? 75 hours. That's how long it'll take to get there. Now I don't care how many days or whatever that is right now. All you care about is how long it will take. 75 hours is your answer. And this one that d equals rt comes in handy. Even though you might not use d equals rt, that kind of setup helps you with other problems too. Okay, I'm going to move on. If you need to pause, go ahead and pause. In the next one we have, you buy a printer that prints 8 pages per minute. How long does it take to print a 40-page document? Well, this one's going to be very similar. 40 pages is kind of like my distance. It's how long, it's how far I want to go, or this is how much I want to make. So that's what I'm trying to equal. I want to equal 40. Now I know it does 8 pages per minute. That's a rate. I know it's a rate because of the word per. So 8 pages per minute. So that's going to be 8 times. You always multiply a rate times whatever you're looking for. In this case, the minutes is what it's going to be. So how long does it take? That's my time that I'm going to multiply by, and it's the per part that tells me that. I'm going to multiply those two values together. Since I don't know how long it takes, I'm going to put a variable there. I'm going to use t. So I can have 8 times t equals 40, or a lot of you might just write 8t equals 40. Now, you can use any variable you want because it doesn't tell you. Now I have another problem I need to solve. I'm multiplying there, so the inverse is to divide. So this is my written equation right there, and then I got to show my work of solving it. Divide 8 to both sides. So I get t equals 40 divided by 8 is 5. Now I need to know 5 what? Well, how many minutes per minute? How long? That's my minute. It's going to take me 5 minutes. And I can always double check my work. Okay, if I'm printing 8 pages per minute and I print it for 5 minutes, okay, that means 8 in the first minute, 16 in the second minute, 24 in the third minute, 32 in the fourth minute, 40 pages in the fifth minute. So 5 minutes is my answer. Okay? That's all I have for today. Have a wonderful night, and we will see you tomorrow in class.